Right. So, Harsh, this is one of my favorite discussions I have both with my team and with people. And unfortunately, I'm always very blunt about it, right? Uh, some of the battery packs I see in India are just horrifying. I mean, when I use the word horrifying, and again, I'm sorry, I'm a blunt guy, right? I would not risk anyone sitting on a vehicle with those kind of battery packs. All right. And we have already seen enough incidents of, accidents, of fire, of malfunctioning, etc., of these batteries. And this is just because of poor design. I mean, I don't know why it's become a cottage industry where people think it's just about putting the cells together, putting some kind of so-called BMS. It's not even a BMS, it's like a PCM, right? All these loose wires hanging, no criteria for thermal management, all right? And that's a battery pack in a steel box if you're lucky, all right, or in a plastic box. Sorry, that's not a battery. All right. I think when we look at battery design, we start all the way from cell, right? Because your application could require higher discharge, somebody else's application could require lower discharge. The thermal characteristics of both the packs would be totally different. And I stress on thermal management a lot, right? Because especially in a country like India, right? We talk about, hey, performance of lithium ion batteries will be bad because when it's high temperature, no doubt. But the problem is also safety. Okay. And there's this whole thing about LFP versus NMC, LFP is safer and all of that. I say no chemistry is safer or non-safe. It's about how you design. So I think a lot of uh, emphasis has to be paid on thermal management, right? You need a proper bus bar design. So the bus bar is not just to connect the cells, but also to transfer the heat, right? From the center of the pack to outward. But then you suddenly see on the outward there is a plastic pack or a steel pack, and how are you going to transfer the heat from inside to outside, right? Especially during charging. So I think the whole build from transferring heat from the cells to the outside has to be given a lot of care, right? And we've done lots of thermal, simulation, not only within the pack, but taking the external environment into play as well, right? And then we have decided how much heat needs to be transferred, and therefore all the materials, etc., have been chosen according to that, right? So I think this thermal management criteria is very, very important. The second important criteria in India is vibration, right? I see these packs with space on the side and top and everything, and all those cells are just vibrating inside. And you know Indian roads, right? So what's going to happen? Your bus bars, your everything is going to break. So there's no this thing. And finally, and I cannot stress enough, I actually had a discussion with DHI, and we hopefully will come out with the safety committee to redo the standards for safety. But one of the things is you need an intelligent BMS. You need minimum string level voltage, kind of monitoring. You need enough thermal sensors in the back. None of that I am seeing, and this is primarily because of the e-rickshaw story and the low cost two wheeler, where cost is more important than a product design. And that's why Greenfuel likes to work with people who want good product designs, reliable TCO, right? We're not here just to capture the masses because we know the problems that could come in, right? So I think you have to pay attention to thermal management, to vibration protection, and especially to your BMS technology, which is monitoring all the health and everything within the pack and temperature monitoring. And it should not only have capabilities for protection, but also correction, right? And
Right.
and that's the key, right? You guys do BMS. I'm sure you know more than I do, but I can see that, right?
There is absolutely every point out you made that I completely agree with you, and I think a lot of folks in the audience do as well.